Hey guys, it's Saturday today, and I have a little talking to do. Recently, I have been obsessed about warehouses, and it's for obvious reasons. I wanted to house some of my hardware components, and given that there are plans to expand and have this foundry where I can store some of my GPUs or whatnot, has been the main driving factor for this obsession. And I was able to do some scouting and essentially scoured around the neighborhood. And I was able to find a few spots, and one spot certainly stood out. And essentially, I tried reaching out to a couple of folks that were the real estate partners that were actually the ones who were, I guess, in charge of the whole yard. But I just did a bit of calculation as well, roughly based on some estimations of how large the area is. It's basically roughly a 13,000 square meters foundry, and I know it's certainly spacious, very large. And I've also wondered the sources of water because, if you're creating a training center, essentially, if you're storing your NVIDIA GPUs and whatnot in a foundry, you need a good source of water supply. So it's certainly a challenge. But the main overarching theme here is I'm currently running a cleaning business based out of North Carolina. This is one of those fun experiments. But generally, it has become my obsession where you could possibly park your car in your warehouse. Every asset of your organization can be stored in that warehouse to some degree. And I also like the fact that it's pretty flat and horizontal and not vertical. And it's one of the surprising things that you'd find in the States is that you don't see a lot of buildings. So it's essentially, you can think of the building as flat out lying on the floor. So it makes it really horizontal driven. So it's like if you want to scale horizontally, it makes sense to have that notion. But I want to do a little bit of planning around this, but this is just what I wanted to share and something that I've been working on. So if you're actually interested in housing some GPUs as well, or if you want some sort of partnership, I'm open to it. And this is going to be interesting and fun and quite a long set of explorations that we can go on the journey together. So looking forward to it. Just let me know. We can definitely make something work together. Hey guys. So in my previous video, I was talking about my recent obsession with warehouses, specifically to store GPUs. One other kind of provoking thought that I've been recently having is a lot about energy density and how much energy you can pack in a single unit of area or volume. When you're working with tensors, that's kind of the case that you are trying to pack more information within a given data structure. And that's kind of the goal here. And I know those are kind of big words, but what I'm trying to say is that the goal is having to really compact and store energy in this unit of volume. If you can store more energy per unit volume, you can release more power because power is a derivative of energy, and that compaction also comes at a cost. So it's essentially this concept that plagues everyone to some degree. Let's say you're working with batteries and you're trying to create capacitive systems that have more capacity to store more energy. The concept of energy density touches every major aspect of physical systems. It definitely applies to computer systems as well, because computer systems are constrained by memory, which relies on physical components that have to densely store information at any given point. Well, given this fact, what can we do to actually push the frontier research or the frontier development of superintelligence? And one area of superintelligence that actually needs improvement is this improvement of energy density per unit space. And if one is able to actually accommodate more information to some degree. So it could be like, okay, we need more memory. That's kind of the obvious thing to advocate for, maybe, right? Or you might be like, by memory, like we need more space essentially. And there are a lot of initiatives around this, but at the same time, you are also trying to see how you can have the logistics of having to move around information. So you might be like, okay, we got to streamline information pathways that these systems kind of utilize internally. And all in all, most these systems are these hidden layers that are kind of creating the connections during the training phase and whatnot. These systems, we might not have the complete observation of what it's actually doing in the training process. And there's an active research around this where people are trying to understand how these systems actually learn and how learning actually forms. So essentially, to a degree, analyzing the learning process of these machines. And it's very interesting because, well, there's the aspect of trying to compact or make things really smaller, denser, but at the same time you're kind of squeezing out the essentially the capacity. So how can you do this trade-off without actually giving up performance? And there's a whole lot of directions to this. My goal here, why I wanted to lay out that as a premise or as an introduction, is that I want to make sure that you understand that there's a huge need for energy. And it's obvious with major projects being built, like the Stargate and a few others, there's this need for huge amounts of energy. And it's primarily because if there's inefficiency, there is kind of overconsumption of energy to some degree. And that's kind of the main driver here. As building a superintelligence company, the whole goal is that you want to achieve superintelligence at a fraction of the cost. And it has been really quite impressive over the past few years what we have achieved essentially with these systems, because we were able to distill information or train information from all over the web, and then we were able to serve it at a very larger scale. But that still took quite the energy. So you can think of the current state of artificial intelligence and LLMs as this, the stage of ENIAC, where we had those vacuum tube computers back in the days, where those vacuum tube computers actually did most of the computing, or essentially they were too spacious and they were too unoptimized. So there is certainly room for efficiency and improvement, though the current state is still quite impressive. So that's what I'm trying to pose here with the concept or with the thoughts of energy density and improving upon that as a main driver to essentially be able to, hey, we need to improve our energy density metrics, though that's not the only or primary metric that we're aiming for, and have these super intelligent systems. And one other key driver or main goal of going on this venture is that I want to make sure that we don't want to leave out human beings. So we already have, to some degree, reinforcement learning with human feedback. So we have RLHF, which is a way of saying we're going to take all the information that humans produce and then feed it back to the RL system, and then essentially use that as a way to reinforce the existing information. So that's the only way that you can suck information out of human beings. But I want an inverse version of that, where we could also have reinforce human beings as well. So I want not just a human in the loop, but also a human being fed back, essentially. So it's kind of cyclical, of course. We're seeing the benefits of reinforcement learning systems. Well, generally, with large language models, we're getting a huge explosion of information back out, but we want to also make sure that we can increase our bandwidth to consume this information. And it's quite difficult to do with the current state of perception. So, we have two eyes, we have two ears, and we're quite limited by some biological capacity or bandwidth. How can we actually retrieve more information? This is an ever-standing challenge. So the goal is also here to kind of have augmented systems where we can benefit from this growth in superintelligence. So those are the two main goals here. One is human centrism, so that we want to center humans first, and essentially the third goal is business, actually. So it's quite difficult to see the motives of companies building superintelligence, but the whole goal is also to help businesses. So business is kind of the key driver here. And most of superintelligence today is underexploited to some degree. And essentially, we have this huge asymmetry of information that is underutilized because we have limited capacity to consume the corpus of information that we get. And it always creates the case where the example I can provide is when we had massive online learning platforms, people were quite excited. So the learning gap was still created, however, because though there was a corpus material or a huge availability of materials on the internet, it was still quite a challenge to learn a whole lot of content without having quite the deepest passion for a given course or material. Even with them today, thought to action difference between, okay, I need to take action on this item and I need to work on this, but it's like the information you get. I was discussing about a thought to action parity that people have or want to minimize, right? So you think about something and then you want to take action on that. But if you're often provided with a large set of information, what you have to do is to kind of reprompt, and essentially you'll be able to take action on that item by further distilling the unit of steps that you're going to be taking on. So you kind of splurge or take a whole lot of information out by simply just making a simple question. So most people would be like, hey, refine your prompt, be specific, but you still have to rely on that. And then there's the introduction of agency or agentic systems, where these systems are essentially trying to eliminate the need for minimal involvement of human systems. And that's also great because it eliminates the need for involvement and it will do most of the heavy lifting for you and you do the light lifts. And that's the goal of technological systems, right? It's all about leverage. But on the other perspective, you also need to understand that there is the loss in learning. That means the formation of memory, the formation of key experiences as you go through certain moments is lost by giving away your agency to these systems. So it's quite a conundrum, and it's a puzzle where on one end of the spectrum, you're trying to improve or be efficient, and on the other hand, you're trying to be thoughtful about your learning process. And essentially, you want to make sure that the human on the other end benefits from the fact that there are learned experiences. So that's also one other key driver here with the whole human and superintelligence alignment. And there's also, when it comes to the need for businesses to extract value out of superintelligent systems, it's the case that speed and a few business drivers are important to this goal. The goal of this company is also to essentially allow people to have, or businesses to have, the right amount of intelligence to take action on at any given point. And the way we do current state of information feeds and the current state of interfaces are quite inefficient for sure. And they are not scaling with the need of information surplus. So it's always the case that there's need for renovating our interfaces or essentially creating a completely, totally different way of communicating this surplus of information. So it's also one of the goals here where we want to address the surplus of information that we have with the current state of LLMs to be able to take critical actions on what is really important and what is not. So I've mentioned 4 goals that are absolutely critical at a super intelligence company. Ironically, it's a cleaning services, so this is not the main thing. Super intelligence is like, it's a fun thing, but it's like, how can a cleaning business really help out in the super intelligence aspect of it? But I find that a little ironic. But hey, that's pretty much the gist of what I want to talk about. But other than that, I'll keep you posted as I develop, as I go, and we're gonna see the whole journey together because you should be involved as well. I hope you're doing well from wherever you are, and let's go build.